Apple's new foundation model framework allows you to use the local LLM on an iPhone. This is a small model and has some drawbacks, for example, a limited knowledge. Luckily, they provided an awesome feature which is tool calling. This is also, for example, used when you use ChatGPT with web searching. The chatbot will then decide on its own if it should call an external tool, so it can then go and search information on the web and then feed this back to the chatbot. We can do something very similar in our own iOS apps. Now, this is a little chatbot, which is a dog trainer helper. So you can ask dog breed-specific questions. And in this case, I am enhancing the model's capabilities with tool calling, where it fetches data from a local file, from a local database. Now, if you have a breed that is very well known, like a border collie, then usually the LLM knows a little bit about it and can give you information back, but we can also force it to fetch some data. Now you see with this generation, I don't really see much what it does. So I added a little, so in this tutorial I'll show you a debug helper view. When I press here, you see the whole session. The first thing is these instructions. You are a dog specialist. Your job is to help new dog owners. Then you see the prompt from the user. It unfortunately gives me one null. I don't know what happened for this. The next thing to execute the user's request, the local LLM decides on its own if it should call the tool or not. In this case, it did call this tool with this name. We can give this name with these two arguments. So search, give me information for this breed border collie. Then you see the next one. Our tool is then called. We do some execution locally for fetching this data from our database and pass it back to the tool. This is the output that we are giving then back to the tool. So here's all different kinds of information, what size, what group, some details about border collies are naturally reserved and reserved with strangers but not aggressive. So all of these information, it's a lot, is then giving back to the LLM and used in responding. For example, you can do this for breeds it does not know. Here the Caracassian is a rather unknown breed. So in this case, I can feed it this now correct information. We can also do some advanced search and filtering in our database. For example, we can ask what breeds do not need a lot of exercise. So it now calls this tool with only the criteria low exercise. So give me breeds with low exercise requirements. And then here in our code that we write with this tool, we can decide what we can search in our database file and say, okay, we are giving back Chihuahua with the information that requires minimum exercise, short walks, and daily playtime are usually enough. And then the other one is the Bulldog. And maybe I just switch back to the normal view. And these are exactly the information that it then uses the LLM to respond, just in a much nicer format. You see here it uses basically the same information that I gave it. Chihuahua requires minimal exercise, short walk, and playtime are usually enough. So we see also how do we help the LLM to call the correct tool with the correct arguments so that we can execute and fetch the correct data. How the data that we're passing back actually influences the LLM's response. How can we make this really smart? And that's also important fast, because you will lose a little bit of speed. It needs to process more. So maybe I do this again. When you press here, you see it before it actually responds. Now it needs to ask the tool, and only then it can answer. The other drawbacks, there's a couple of drawbacks with tool calling in general, not just with the foundation models framework. We're making our context window longer because we're needing to put in the information for this tool. So usually you should not, especially with this rather limited model of 4,000 token context size, you should probably not put in too many tools. You can add multiple tools. For example, right now I only have one tool where I search a database, but you can also, for information, you can also do something, find a dog trainer near me. So you would need to use the location and the maps or some searching. Or we can do some other stuff like updating a training plan. For example, the user can say, I did this with my dog today, update my training plan, or set a reminder for this play date. We have a different tool that then, for example, sets a reminder or schedules something, updates a progress view that you have in a different style. So you can also execute as a side effect some tasks in your app. We're not going to do that. We are concentrating here on fetching information from this database, so you can see all the ins and outs and some complications involved. Overall, I am quite happy with the result. You will see at the end. You can find the link to this project in the description box. This is already the second part in a series. If you have never worked with the Foundation Models framework, you can also find a link for the first video in the description box. So go ahead and watch that so you understand the basics of this framework, because we're going to build on top of this now. Okay, I am now back in the project that I finished in the last tutorial. The main things that we are going to work on is in the chat view model. Here I have my language model session and a function send message where I use the session to stream and execute user's request. Then we have this partial generated response that we are showing in the UI. Now, when we work with this language model sessions, when you create a new session, it's like a chat with response and with user input, with user prompts and responses, user input, response. When you create a language model session, you have a couple of extra leverage points, and one of them is the tool. So this is the argument with tools here. Okay, maybe I just add this to mine. So this is the tools where you can pass in an array of tools. Tool is a protocol that we have to conform to. You can, as I said, add multiple tools. However, I wouldn't recommend too many. I tried to add multiple, and because they were so similar, it got confused which tool to call. It also got really slow. The more tools you are adding, the more space you're taking up in the context window. And this just doesn't scale very well. So be careful. We are just going to, for this example, adding one tool. So here in this view model folder, I'm creating a new file from template. This is a Swift file for our tool. I'm naming this breed database tool. I need to import the Foundations model framework and start creating one of these tools. If I declare this as a struct and conform to the tool protocol, yes, you see it has quite a few requirements. Let's start with the easy ones. The first thing is we have to provide a name, and in this case I'm calling this search breed database. This name we can use in the prompt and instruction, so it understands, oh yeah, use this tool. Then we have a description. This helps the LLM to decide when to actually call this tool. What is the purpose of this tool? This is especially important if you have multiple tools, and you should really try to make the description and the name as clear as possible and not ambiguous. Otherwise it's like, which one should I call? And then it calls the wrong tool with the wrong arguments, and then the user gets a response back that doesn't have anything to do with what they actually wanted. So this is quite an important thing. So search for dog breeds based on criteria, or get details about a specific breed. Okay, next. I need to, as I said, we have to communicate. The next important function is actually the call function. So this is the interface between the LLM when you type in with your prompt as a user. Then the LLM goes and decides if it actually wants to call the tool, and also how it wants to call the tool. What arguments does it pass? What does it actually want? In our case, we see we have certain criteria and information for breed names. And these arguments, this is something that we have to actually here write ourselves. This is a struct. What did I say? Let breed name type string. Now this is a string, so it's a Swift type, but I said this is an interface between our LLM. The LLM will actually call this function, and basically you can imagine that how does it know about our Swift type? How does it know that it needs to specify a breed? Does it use JSON? How does this work? So we're not using JSON, we are using the general macro. This is a macro, maybe just let me expand macro, that adds a generation schema where you see all the properties. Here it says breed name of type string. And this schema is the way it can interpolate between LLM language and Swift language. In this case, this schema is injected into the model session, so the LLM knows, oh yeah, we have this kind of schema with breed names and strings inside. There's also some other things like the generation, partial generation. This is what I use if you would do streaming responses. Now we have something that the LLM can talk to our tool, and here I, as the developer, can write my fetching code. This needs to be arguments. Now we need to return something. Let's say I did add to the project a JSON file with some information. So you can just copy one of these texts over. So we are feeding, this is what we are feeding in general back to our LLM. I will work on this a little bit later, just so we get this runtime going and see what's actually going back and forward first. Now that I have a basic tool, I can go back to my chat view model. I wanted to add this tool to this tools array. So we can use a beat database tool. I also should keep in mind that I need to do this when I reset the session. This is when I press reset, I create a new session. You might also want to create a function that generates this. Okay, let's try this one time. This one same sentence. But the main point is to see that it actually uses this, hopefully. So now I press here, what breed is the Caracassian? And now it will actually get the border collie info. So then it might be a little bit confused. And you see, I have the problem, I don't actually know if it called this tool. You can add here print statements, but the better strategy is to have a look at the session, what is inside the session, and it has a property for transcript where we see all the prompts, the instructions, and also the tools. So before I proceed, I want to have this little test helper view. This is a new Swift UI view, which is my history view. My chat history view. I need to start importing the foundation models framework. And the thing we are going to look at is the session. This is a language model session. This has a property that I want to show in the list. This is the session transcript. The transcript is basically an array of these session elements, which can have different types. I'm just going to remove the preview. In this case, it doesn't really make sense because I cannot generate a default one, a test one. So switch entry, it struggles with the type. So the workaround is that I create a subview, file private, entry, struct, entry view, where I pass in the entry of type transcripts entry.description, and here in this list I call this. So this is the entry view for this entry. Now what you also see, it doesn't complain, for example, that list here needs for each. As you see, each of these entries has an ID, so these entries are identifiable. They on purpose did this. We have something we can use for debugging, which I'm very grateful for. This is the description. Now, to make this a little bit more useful, I use switch entry, where you see all these different cases. For example, in the instructions one, we get the instructions. Again, it has an ID, a description, the segments, and also the tool definition. Let's just do this one time. Text, instructions, description. Let's make the instructions more prominent, just so you know the difference. Okay, so case, the prompt. You see the options when you generate a response, you can change the temperature and some behaviors. In this case, I'm going to use the descriptions. Then the ones I actually want to use is this tool calling. This is the tool description and the tool output. So in this case, I want to have a look at the tool name. So this is the segments. Or did I forget anything? Ah yeah, I forgot the response. So the response is just using the description. Now we have one more unknown value. Okay, so for just because you see there's a couple of cases and I want to make this understandable, I put this in one cell, so this is a VStack. The instructions are first, then we have the prompt, so what is the user asking for? Then we get the tool calls. This is from the LLM asking the tool for information. Then we look at the tool output, and then the LLM uses the output to generate a response. The one that the user actually sees is the prompt. So I make these ones bold and foreground color, foreground style indigo, just to format this a little bit nicer. It's just for debugging for us anyway, and the response. So I just get a better idea for myself, which is which. Now we have our little helper debug view that I want to attach to my main view. This is the one that we want to add in content view. I already added a toggle show history button that currently does nothing. So what do I want to do when this is true? Instead of the chat view, I want to show this one. So this is an overlay. If show history, then I want to show this, and this is in the view models session, which I made private. So I go to the chat view model. The session is private, so I'm going to make this private set. Now we can see in this chat model, I added the if debug. You can also add this if debug to this overlay. The whole point was, it looks a little bit complicated, but it's really worth it to add this history view. Otherwise, you just don't know what's going on. This is this button. Currently, we don't see anything because I still have no messages. So now I press the first one. And you see we have the instructions. So this is the instruction from our view model. You are a dog breeder. This is the first one we see. Then I said we want to have the tool definition. So what does the LLM see? We have the name. This is the one that I wrote here. The description, this is helping it decide what to do with this tool. And it also gets the information from this arguments. You see properties, additional properties, false. Properties, breed name, string. Required breed name, optional. Title, the order. These are generated from the element in the order you're defining them. It looks like I have these instructions twice. This is because I have the instruction description. So that's why it's double. Maybe we're just taking out this one. So you at least saw this one time, that it actually is part of the context window of the session. I'm just removing this because it's a little bit too long. Okay, then the next thing is I have here my prompt. When you're using these LLMs, you can also return structured output in a certain format. Instead of just to see this here a little bit better, we can use the segments description. So I only see the prompt and not the response formatter. Okay, so we're starting with instructions, prompt, then it calls the tool. We see the name, search by database. The search by database is the name that we gave this tool. Then what arguments did it pass to this tool in this call function? Then the next one is the response or the output of this tool. So we see the name of this tool, by database, and the output is exactly what I provided here. So we have the output, and the output is used for the response. You see border collies are known for their intelligent energy levels. So this is then used here. Let me just check and rerun this again in my debug view. And the reason why I have these double is because here I forgot to remove this text with the entry description. Now I only get my formatted things. Okay, try again. Press here in my debug preview. Now we have the instructions, the prompt, the tool call, the result of the tool, the output of the tool call, and my response. Just going to add here. In this case, because I'm only having one tool, I am going to, for the tool output, just uncommenting the tool name. So we can just focus on what the result was. You can also change this to more descriptive output of tool with an alignment of leading, and I try again. So it calls the database tool, we have the output, and then it generates this response. Now that we have this debug view, I can continue working on this tool. We can see if we are moving in the right direction. If I go now to my breed database tool, you see I currently just return always the same thing, which isn't good. For example, if I look for a different breed, now it calls the breed for this one, but I return the information for a water color, which is not really what I want. So we need to update here and return the correct information. I did add in this project a load dog breeds helper function, which loads the JSON file that I have here. So I want to load this for this tool, so the tool has the correct information. Now, because of this tool needs to keep some state and needs to keep reference to this information, which means I am going to change this to a class. This is of the type that I added here. This is this whole breed info data structure. And the initializer, I am calling this. Now this has the correct information and its reference type, just making this final class. Now in my chat view model, because of this session reset and because it now has state, I am going to keep reference to this. This is a private var tool, my breed database tool. And the initializer I set to this new tool. And I pass this one here. I need to first create a property before I can actually assign this. And then, because I don't want to do this again when I reset the session. So this is after I have here a session and I press restart. I will reset the session, but I want to use the same tool. I don't want to reload the data. So here, when I recreate the session, I again pass this tool. Now I am ready to do the proper database fetching. So I can now use this array, and I'm using first where the breed name is equal to the argument's breed name. If let, or I should say guard let result. We have this, else, and now I am returning here tool output, and in this case I will return and tell the LLM I couldn't find anything. Could not find details about breed arguments. If you can't provide the information for this tool, you just return in natural language what happened, because the LLM will then use the information you gave here to respond to the user. So it's best to have a normal English sentence. Okay, if I have something, I want to return this here. Now, this is of my special type. So we should actually complain here. This is not matching the initializer, so the initializer that I want to use, because it's not a string anymore, is generated content, where the content is convertible generated content. Some of the types like string automatically conform to this. And now we have does not conform to this. How do we conform to this? It's the same thing as I did here with this generable macro for my arguments. This is basically whenever you need to, you can just rethink this. Whenever the LLM needs to talk to Swift code or pass things back and forth, this is the way they translate from LLM language to Swift language. So in order to return this here, my type of this breed info also needs to be known. So this is a generable. Need to import the foundation models framework. Now it's going to complain that it doesn't work because all the types that are in this struct need to be also generable. So I need to pass this to the other types I have here. So this is the reboot. This one, import foundation model framework. This is in enum. There's nothing special, so it's automatically conforming. Then the size category I'm also using, again, a generable. training recommendation, a generable, and trait details. I'm also making generable, and here also this enum. This one I'm going to use as a second argument for my tool call, so the LLM can fetch for certain traits. So let me see. Okay, now this arrow should disappear. So let's try again. I ask for border collie. Now we are searching for border collie, and we see the whole tool output for that. This is all the information, which is a little bit too long, that I had in my JSON. So you can look here, it should be this whole information, which is quite a lot, and probably if the user just asks, tell me about dog breeds, about the dog breed border collie, this might be an overkill. You also need to remember that this whole text here is now part of the session and takes up space in the context window. So it takes up space for this 4096 tokens. So when you add too much tool output, it will add up quicker and the session will exceed the context window faster. The other thing is, and now the LLM has a little bit of trouble how to answer this. And you see it feeds all this information because I gave it all of this. So when the person asks, this might be an overkill, what they want to know. If you don't want to feed everything back, you can use a different output. This is return and all output. Need to have a different initializer. These types can be a little bit, it needs to be, okay, so we are going to use the general content, this one, and have a look at different arguments. So I use the content one where I can just pass the whole struct back. You can pass a whole array of these. As you saw, it was already long enough, at least not for my use case. It's maybe a little bit too long. You can also use properties. In this case, it's a key value pair of string and convertible to generate a key. So again, something generable. For example, I can return here only specific things, saying breed, and this is the one result, breed name, and then let's just say size, some of the properties I have in this array. This is the results size. This is of size category, but you saw I made everything generable, so it's just going to accept everything. Group. You could have also, which I thought afterwards, maybe a short description or like a small paragraph that you can use in these cases. And then here traits. So this is the results and traits. This is a little bit shorter because before the breed info, I had also training recommendation. So we're already cutting it down quite a bit. You can then here decide maybe something shorter. I need to actually use this output and return it. Otherwise we won't see it in our tool call chain. The border collie. Now you see it's a little bit shorter. Maybe just do another one which is anyway shorter. With this one it struggles a little bit because it does not know about this. Sometimes you see the tool needs to, I'm not really sure what it does behind the scenes. Usually you get a couple of errors. So in this case it could not find the cache. I think I did something with the breed names. Sometimes with these breed names or matching terms, the names are just different. For example, if you're looking for a Jack Russell Terrier, they might search for Jack Russell Terrier, Jack Russell, or the short abbreviation GRT. So that's why I added matching terms. We're going to use that one, which makes it a little bit harder because this is an array. But I did add, let me just, a helper function that helps me match these with the terms. We're going to use that function. This is just what the user enters and you don't know sometimes, so you need to be quite flexible. So here when I search, I use matches name. It's not like super deterministic compared to what you usually do in code. You can use some regex expression to understand what's going on. I need to make this lowercase because that's how I did it. Okay, now I use the argument's breed name to filter from my database. If you're looking for the border collie, it outputs this. If I go for percussion, it finds it and returns this one. Now, the interesting thing is, for example, if you have tell me about golden retrievers and Labradors, in this case I should fetch them twice. It calls this tool for Labrador retrievers and for golden retrievers in parallel. The LLM can call your tool as quite often with different arguments, and it does this in asynchronous, just to make it faster. In this case, we have the result for the golden retriever and the Labrador, and then it generates this full response. But this is one of the things I wanted to show you with this tool calls. So it can call this tool multiple times if you have different tools. It can also call them in sequence. So it fetches first this information from this tool and then it does this with this other tool. So then you would see them called one after the other. So the next kind of thing I wanted to test is, for example, how much grooming does a poodle need? As I said, I'm just dumping the whole information back. I don't want to do this. I would rather, since I have these traits, add certain traits. And in this case, it also doesn't actually call this tool. This sometimes is a little bit annoying. So in this case, it directly skips over it. One thing you can try in the instructions, here you can add multiple lines. Since I want to force it, one of the best practices is to use capital U must, pretty much like shouting at it, you must use the tool. I need to type the same name that I had here because, as you saw, it knows from the schema. You must use this tool if the user is searching for breeds that match a certain criteria or breed specific information. Either you use capital you must use, or you can say capital do not do this. It is helping a little bit. So try again with the poodle. So it does use this tool now, but I have too much information here and we want to filter this. The first thing we need to look at in this tool is to filter this better to only return the traits I wanted. In addition to the breed name, I want to have the trait, which is either one of these, like good with children, good with other pets, and then an explanation. I tested a couple of data structures. You can also define different ones. Let me just show you so you see what I'm talking about. The next thing is not always when the user prompts, like for tell me about the dog breed border collie, here there is no trait. But I also want to have a situation where I can ask which breeds do not need a lot of exercise. So in this case, I don't even have a breed name. So we're going to make both of these optionals. So now here it starts to complain and we need to add more if statements to this. And the first case is if I have a name, else if I have a trait. So basically, if I don't have a name, I'm just searching for breeds with this trait, search for breeds matching trait and need specific information. Let's get this done quickly. So I move the guard statement in here and this output also in here. Else, if everything is nil, my traits and my arguments, I'm not really sure if that ever happens. I'm returning could not, no arguments provided to search, and just going to return array of breeds here for now, just so it compiles. Now that I have a name, I can use that to filter. And then here, for this output, I want to check if I should filter also these traits. So let trait var traits. I first create a copy and then I check if that trait arguments.trait. Then I want to override this. And the problem is sometimes it doesn't get the right one because the way I wrote it. And I actually need to not use it. I need to actually use here the right treat. separate trait. So this enum, I'm telling it to use this enum, and now I can use this filtered traits to pass them here in this traits array. Okay, let's see if my filtering worked. So in case I am searching for a breed, like the border collie in general, I should still see all the results. So you see still this long answer. If I am looking for something specific, like are bulldogs easy to train, I should call the tool with the breed name and the category. And here is where things get complicated. So it does search for easy to train, but it forgets the bulldog. We start for poodle. Now it should give me poodle and grooming, and it struggles again. In the next tutorial, I will talk about how to enhance and fix this. But you see, if you're trying to do too much, it gets confused. Also, this is a local model that is not the smartest. But generally, we had the tool call correctly. I mean, kind of working. So which breeds do not need a lot of exercise? Now, it calls low exercise, and I did not provide the correct output because this is just return array of breeds. Okay, let's now work on this. I am using this array to find the trait where this is matching. And then I want to use one of the other elements here, and I return this is our results. Actually, this is an array of breeds. And let's try again. You already saw that the tool was correctly called. So what breeds do not need a lot of exercise? Let's try high energy dog. And this is now a substance of array, so I'm just going to... Okay, now it works. It calls it correctly. And we see our two results. And you see it's really long, with way too much information in there. That's why it crashed. Also, if this is a lot of information, it needs to convert the text to tokens, and it might crash, or as you see here, it's slowing down things. And in this case, I really don't need to return so much information because I just ask about if a dog is easygoing. So we don't need to have the whole information of all breeds. We want to keep the LLM focus on the user request. I am filtering the traits array, if they're easy to train, easygoing, grooming requirements. I'm filtering this and only want the one trait that matches my search term. Then I map this and only return the explanation. So for example, if the user asks good with children, then I'm only returning here this explanation. So it's a rather short response now. And I'm formatting this as a string. And here, for my generated content, I am using the properties again. Okay, let's try again. The good thing is, I will see if this is the format that I wanted. So, not a lot of exercise. We have the low exercise, and indeed now I get my two breeds, Chihuahua and Bulldog, with this rather short returns. And this is great. You see also that it condenses this down. So it's much faster. You have much less information. It's very focused on the task, so the LLM doesn't go on a tangent to write 500 words. Now that I've fixed my little information overload, I can increase this to 5, for example, here to have the first 5. I have 3 return types or 3 return values in this array. You see here the formatting that I used. This is actually because of the formatting where it says Basset Hound and then the explanation. This is the same style formatting with the same text, so it requires minimal exercise. You see Basset Hound requires minimal exercise. So the LLM takes in the tool output and then formats it nicer and returns it to the user. So this is one way of steering the LLM. You want to take advantage of what you return here in these tools. The other thing, since I have this filtering kind of going, if the accuracy of that the tool calls the right filter, sometimes we have allergy friendly and it needs to use hypoallergenic. Sometimes these don't work very well and you just can't infer. Dogs don't shed a lot. Low shedding, this works also. There was one that always does not bark. Here you see it's quiet low barker, and I had to change this Initially, here I had low Barker, and then it sometimes couldn't understand this. The thing is, the LLM needs to generate these cases, and if the words don't make sense, it means this case. Sometimes it can't, and then you need to try different cases so it understands better. The problem is you might tend to add more cases to these traits, to these arguments. Here, you might want to add more and more cases. The thing you have to remember is that the LLM has this in context. The more cases you add, the more it could choose the right one, or it could get confused because there's multiple ones that are similar and ambiguous. So you don't want to have too many because of the context window. This is one of the things you need to watch out for. One thing I did not talk about is here guides. So this is another way of helping it out to understand what you want. So you can say a specific to search for example, low shading with children. And I found with the optional, sometimes it doesn't get it right. You can do this also with this trait. So the exact breed name, so for the exact breed name to retrieve details for if present, in general low shading or good with kids. The thing is, because I have here this type, it knows about all the cases and it forces that the case enum works. So always take advantage of this guided structures or enums. The other thing is, for example, in a future edition, you might want to have multiple traits. So breed trait. In this case, you can use a guide with count. So for example, they have a couple of these guides here that you can add. You can say for an array, give me 0 to 5 traits. And it would then take this into account and not give you the other trait, more than 5 traits. For example, maybe you only want to say maximum of 3. The question is, if the user puts in more than 3 traits, things get complicated. This is something that you can also take advantage of. There's more of these guides, which I might talk about also in the next tutorial, where we're extracting some information from the user's prompt to see what's actually going on. You saw that I used this tool to enhance the knowledge of the local LLM, and we used this history of the chat, the sessions transcript, to see what's going on, what's fetched and returned. Most of the examples that I have now, it works pretty well. Sometimes here, for when I have 2 things to consider, like grooming, it doesn't do it correctly. You see here it's missing something. It's just requesting poodle, which is kind of okay because we're still having the right information, just too much, which then causes it to sometimes go too much into detail. Let's try this. Unfortunately, in some cases, like how child-friendly are Chihuahuas, it's not searching for dog breeds that are good with children. The information is not the best breed for families. It's what it used from its own memory, not what I feed it. So this is one of these cases where you see, because as the user prompt is more complex, the LLM might miss something. As I said, this is a local small model that is rather limited in its logical abilities. And I'm going to show you a sneaky trick. Okay, this is a common best practices. This is getting more best practices for enhancing tool calling. So I do use something, and it's a nice example of taking advantage of guided generations. One thing when you're doing these tests, I have a collection of test cases. I used here the suggestions. In the real app, in the final production, I would not have so many test cases. I just added them more and more to see which one actually work and which ones I continuously have to, just a couple of different edge cases. So I keep track of it if it's working or not. Going here manually is not the most fun. So it's best to write tests for this, and I'm going to show you this. I will add this to this project. In my project for the tests, I had a little helper with the test cases. So I know what prompt and what expected tools I have and expected tool results. For example, when I use the prompt, how child-friendly are Chihuahuas, I expect that it calls the tool with the breed name Chihuahua and the trait good with children. And that the expected tool results should also contain Chihuahua. As you saw, I did not do this in the beginning for one of these cases. So this is the one I use with self-testing with the multiple tests. And here I use this session from my view model, so it has the right parameters. Then I'm just taking the expected calls, the prompt, and here I execute the session to respond to this prompt. This is a one shot, not a streaming, because I'm testing. And then once it's finished this response, I'm then looking at the session's transcript to check, did it call this tool? And what was the output? Because the tools can be called multiple times, I'm just collecting this, and here at the end I'm checking, did it contain the names the breed names that I set? So let me just run these, I don't think 16 cases. This is basically the cases you saw also in my app suggestions. In this test case plan, under options, you can say if you want to parallelize them, so if the test cases should execute parallel, these tests can execute in parallel. Each of them has their own session, so you can run them in parallel with each one executing. You can also set them in serial, and then it will execute one by one. This is good if you want to know how long each prompt will take, because then you see how the duration of each of these tests, okay, this prompt took 30 seconds to fully execute. This is a little bit too long. Some of them are 10 right now because it's doing all of them at once. The local LLM that I have on my Mac will have to distribute resources to all of them. Okay, we have one green one. For the test case, tell me about golden retrievers and Labradors. We have one that failed, which is how child-friendly are Chihuahuas. This is the one you saw me struggling. So if I look here, we see that the expected tool calls did not. So we have the missing Chihuahua for this prompt and tool call. So the database only said search for good with children, which is the one we always saw. So we have another problem with the border collie. So this one has a problem, the children and the grooming for poodles. So we have 3 failed, 1 of 16. You can also have a look at this test plan with more information. So this is then giving me here which one it's supposed to call and which ones it did not call. So we have 3 failed, 1 of 16. I recommend you to really run these tests also with serial, so you get the proper durations here and you see, if you make some changes to your instructions and you suddenly have, instead of 10 seconds response time, 30 seconds, not good. But the thing is, as a recommendation, collect use cases, prompts that cover a wide range of app user intents. Some that also don't work, so edge cases, and then run them here. When you optimize for your instructions or some of the things that I changed, like the tool call here, if you change the tool description, each of them can have an influence on the outcome of your tool call chains. So it's good advice to test this once. It takes 2 minutes to run all of these, but it's still faster than manually. The other thing is, future LLMs for each iOS version update might have changes to the local LLM. So when you go from 26 to 26.1, 26.2, they're shipping updates to these local LLMs, to the on-device models, which then can change the output of your instructions here. So at least run them to save these test reports. So for all of these test cases, you can compare, did it improve or not. Testing is not so popular, but in this case it really helps, especially when I had some tests where I was trying different instructions. This strategy of automated tests just made it so much faster. But as you see, it did get better with the last update for Xcode 26 Beta 3. Also, it's the update for macOS. So just have a look at this. You saw that it rather reliably called these tools now. In some cases, it struggled. And the reason, one thing I actually did not take advantage of right now is adding examples or explanations to what tool to call. I don't want to put this in the instruction of the main session because it just gets too long and confusing. So we're doing a little trick in the next tutorial where we extract user intent from the prompt. I run a separate session where we do these extractions ourselves. So you learn more about guided generations, structured output. Similar to here, what is the arguments that it actually produces. So we see a little bit more about these, how to enhance this in a good way. With these LLMs, you need to do a lot of fine-tuning and tweaking to get it to a production level. The next tutorial really pushes it further, so go ahead and watch that here. Thank you for watching. Happy coding. Until next time.